Okay, hey everybody. Hang on one second. Let me get everything else ready here. Oh yeah, there we go. Okay, I just realized the microphone wasn't on. Okay, so anywho, let's get started. Brain's a little scattered because I've got so much more to do today. I'm just like freaking out a little bit, but we'll take it one step at a time. We've got about 30 minutes here together, so we're gonna try to plow through some of your math. I'm gonna put out a quiz tonight, and the due date will still be on Sunday night. I know that's kind of tight, but again, you can retake as much as you need. It's not graded, and if you have any questions, post them anytime leading up till Sunday night, 11:59 p.m. And without further ado, let's get to it. Okay, these should be pretty clear. And remember, on the quiz, I'm not looking for answers. Sure, your answers, let us know if the answer is right, but really the answer only is right if your method is right. So I'm looking for the method. I'm looking to see your work. I'm going to show you exactly on here what I'll be looking for, and if you've been working any of the problems that we've been doing thus far, you're going to be just fine. This is not going to be intense, okay? Because I don't think tests should feel intense. They should really feel like just another rehearsal, okay, if it's done right. So let's get started. Before we get started, you'll notice there's a tone there in the back. I put a link in the description. This is a particular tone that's demonstrated to enhance your focus. Now, to really use this tone properly, you have to listen to it for a full 30 minutes before you start working. So I encourage each of you to click the link that I put here in the description. It'll take you to a page that plays a 40 hertz tone, and listen to it 30 minutes before you need to read a book or study or work on something. I've also linked the research paper showing that this isn't just fairy magic, because y'all know I believe in science, I believe in data, and I believe in facts. I'm certainly a person of faith, and I'm certainly a person of vision, but I think faith expresses itself and is most revealed by facts and data, not obscured by it. So I encourage you to check it out. I've also linked the doctor who I learned this from, Dr. Andrew Huberman. So he's a neuroscientist out of Stanford, and he does a lot of good work and does a really good job of giving you science-based, real techniques, or rather, he does a really good job of translating scientific research into stuff you can actually do. He takes a whole bunch of jargon and turns it into things you can do and explains it in ways you can understand. So really cool podcast, really great guy. I encourage you to check out his work. But that's that. So I'm gonna play it throughout this review session, but I'm not gonna play it in the others, as you want to listen to it before you start your work. So going forward, if you find it helps you, give it a shot. 30 minutes before you start working, but it's a choice. You don't have to do it at all. I found it interesting, and I at least wanted to give you exposure to it. So there it is. Posted all the references in the description. Go check it out for yourself. And now we can finally begin. So let's get started. Last time we talked about, at the school, we did our best. That was a little intense. But whatever. We talked about squares and cubes and square roots and cube roots, and today we're going to pick up with that. If you've had any questions, please make sure to reach out so I can address them. One thing I've learned about teaching through video without actually having your direct participation right then and there, it's different if you're in the comments or chat at the same time. But if y'all are watching this on your own without me there, it's hard for me to gauge what you do and don't know and what you do and don't understand. It's very, very hard. I'm essentially talking to a camera, and that doesn't tell me anything about what you are keeping up with or not. So please make sure to communicate with me and let me know if you don't understand something. But if you do understand it, great. And I'm trying to present it in a way where I sort of answer questions ahead of time and you can sort of see what's happening as we go. So, all right, so last time we talked about squares. We talked about how 5 squared really just means 5 times 5. And that a lot of people see 5 squared and think, oh, 10. But it's not 10. 5 times 2 is 10. And remember that 5 times 2 never really meant times 2. It meant 5 plus 5 2 times. That's why it's called times. Okay? Times always meant plus. It just meant plus a certain amount of times. Exponents genuinely means times. So exponents mean you take 5, and in this case, to the 2 times. If you have 5 with a little 4, that means you take 5 4 times, okay? You're going to multiply it 4 times. That's the difference between exponents and multiplication, all right? I think we did a decent job covering that last week. Let's just do a couple of practices here real quick. 5 to the 1 would be 5, okay? 5 to the 2 would be 5 times 5. 5 to the 3 would be 5, 3 times, so 5 times 5 times 5. So you just take this here number and multiply it times itself this many times. Or if that's a tongue twister and a little bit just too much to hold in the mind, you take 5 and just write it 3 times and then put a time symbol in between them. That's it. Okay? Now you try. I'm going to give you a couple. Make sure to pause me after. I'm trying to make these videos shorter so you can fast forward through them quicker. So I'm going to give pause warnings and then that's it. So just pause it if you need it and then I'll move on. Okay? So let's do 10 to the 3. Let's do 8 to the 6. And let's do 4 to the 4. And I just want you to write these out. You don't have to put them in a calculator. Okay? When it comes to actually putting them in a calculator, you can do that at any time. Okay? But that's something you can do on your own. Pause now. Okay, we're proceeding with the answer. All right, here we go. So this one should look like 10, 10, 10, and then I'll just put time symbols in between. 3 10s. This one should look like 8, 8, 8, 8, 8, 8. Time symbols in between. Done. This one should look like 4, 4 times, so 4, 4, 4, 4. Boop, boop, boop. Done. Okay, put it in calculator, be done with it. Exponents in a nutshell, okay? We haven't talked about negative exponents. We're not going to do that yet. We're going to move on. Okay, let's talk about square roots and cube roots. And these problems up here we covered last time, okay? So if you feel like it's shaky for you, let me know in comments or email or call or any of the other methods that we've utilized. But this should be pretty solid for you now, okay? Let's look at roots, okay? The root of an exponent is the exact opposite. So 5 squared is the same thing as 5 times 5. 5 times 5 is 25, okay? So 5 squared is 25. A square root is the exact opposite of a square. So if you take the square root of 25, you get 5. Let's take a closer look at each part of this square root so you can understand what's going on in it. This right here, let's color it. This right here is the radical, okay? This is called a radical. This is the thing that tells you you're going to take the root of something. It looks like a division symbol. It really does, okay? One way you can tell it's not a division symbol, besides its kind of odd shape, is the number that's inside of it. This tells you what exponent it's supposed to represent, okay? This radical with a 2 is called a square root. It's called a square root because it's got a 2 in here, which is what we've been doing. We've been doing squares, right? And it's called a root because the radical represents you're taking a root of something. We're taking the square root of 25. This 2 here, this exponent that represents a square, lets you know you're trying to figure out what number times itself 2 times, note this number right here, what number times itself this many times will give you this. 5 2 times will give you this. And if you want, you can do your answers like in a rotation like that. After you get an answer to something, you can ask yourself, does this answer this many times give me this? That's what roots are. Okay, today we're going to talk about square roots and cube roots, and we'll explore a little bit of what to do with them. Okay, so let's look at another one. I'm going to leave this right here. Let's do the square root. I'm putting a 2 there so you know it's a square root of 16. And what we're asking ourselves is, what number times itself this many times, so 2 times, equals 16? Now, if any of you just said 8, remember that 8 cannot be it. 8 times itself, 8, is not 16. 8 plus 8 is 16, but we're not doing plus, remember? We're doing exponents, which is times. So your goal here is to look at the number, what number times itself, or what number written 2 times will give you 16. 4 and 4. Bloop. So the answer to this is 4. Because 4 2 times gives you 16. Remember with exponents, including roots, that we're talking about multiplication. So we're talking about what number times gives you the number. Let's work another one. Put a little 2 in here. Okay, let's look at the number inside. What number times 2 times will give us 100. And I just realized I worded that really strange, but I'm hoping you kind of are okay, because we just talked about it a little bit. All right, so I'm gonna write the number. Let's just say you said 50 on accident, because a lot of people kind of struggle with that at the start. They're like, oh, 50 times 2. Remember, 50 times 2 means 50 plus 50. We're talking about times, so I'm gonna write the number 50 twice and put a time symbol in between them. Does 50 times 50 give you 100? No, sir. 50 plus 100, 50 plus 50 gives you 100, but not times. So it can't be that, okay? Instead, 10 twice, so 10 times 10 will give you 100. So the answer to this is indeed 10. And look, you can check it. 10 times 2, or sorry, not times 2. Ha! 10 2 times gives 100. See, even I have to remind myself, okay? All right. Let's have a look at another one before we proceed. And then I'm going to give you a few more to work on your own. 81. Let's put a little 2 in there so you know we're just doing this 2 times. What number times itself twice will give you 81? Pause me if you need. Okay, here comes the answer. So let's have a look. If I write 9 2 times and then just put a time symbol in between it, remember, why did I only do it 2 times? Because there's a 2 here. 1, 2, 2 times. Okay? So fine. Oh wait, let me leave those there so you can see where it came from. 9 times 9 is indeed 81. So the answer to this is 9. And remember, you can cross-check it by simply looking at it backwards. 9 2 times does give you 81. When we say 2 times, we mean 9 times 9. Okay? Not 9 times 2. 9 times 2 is not what this is. This number right here tells you how many times the number is multiplied times itself. Times itself, not plus it, times itself. Okay? Now you try. Square root of 121, square root of 144, square root of 49. Pause me now. All right, if you haven't paused yet, last chance, getting ready to reveal the answer. Oh. There you go. Sorry, I didn't put the 2 in there. It's very important. Okay, now getting ready to reveal the answer if you haven't seen it already. Okay, here we go. All right, so what number times itself will give you 121? All right, I'm going to put down 11 2 times. Then put a time symbol in between them. And lo and behold, it does give 121. So the answer to this is, I was going to put an equal sign there, but Answer to this is 11. What number times itself twice will give you 144? 12 and 12. So the answer is 12. What number times itself will give you 49? 7 and 7. So the answer is 7. Okay? Now some of you may have looked at these and said, yeah, Mike, 10 times 10 does equal 100, but so does negative 10 and negative 10. That equals 100 too. And you're right, it does. I'm trying to keep everything kind of organized. All square roots have 2 answers, the positive version and the negative version, because 2 negatives always give you a positive. So those of you who spotted this earlier, congratulations. The answer to this is actually negative 10 and 10. The other way to write this is simply to put a plus minus in front of the number and be done with it. So all square root problems then should have a plus minus in front. When I say square root, I mean if it has a 2 in front of it or any even number at all. Let me show you what I mean. The square root of 10,000, or sorry, not the square root, the 4th root of 10,000 asks what number times itself 4 times will give you 10,000. The answer to this is 10, 10, 10, 10. Okay? So the answer of the 4th root of 10,000 is indeed 10. But remember, since there's an even number of numbers, there's 4 numbers down there, even if I put a minus sign in front of each one, these 2 negatives will make a positive 100, and these 2 negatives will make a positive 100. And positive times positive is positive. So when you have an even number in your radical, or an even number in your root, whatever you want to call it, I'm okay with you calling it a root or a radical. Whenever you have an even number in there, you will always have 2 answers, the positive version and the negative version, always. So let's do plus minus. And you got it. Plus minus 10 is the answer to that. So let's go back to these other ones and fix then what are really just half answers. This is plus minus 11. This is plus minus 7. This is plus minus 12. This is plus minus 9. This is plus minus 10. This is plus minus 4. This is plus minus 5. Everything we've done up to this point was only a half answer. Okay? Got it? Okay. Now you try. Square root of 4, square root of 9, square root of 36. Give it a shot. Pause me now. All right, by now you've unpaused me. Hopefully you've been doing your plus minus. If not, pause me now and make sure to hit your plus minus because these are all even. All right, we're proceeding with the answers. What number twice will give you a 4? 2 and 2. Very good. So the answer to this is plus minus 2. What number will give you 9 if you do it twice? 3 and 3. So the answer to this is indeed plus minus 3. What number twice will give you 36? I forgot what font I was using, y'all. 6 and 6. So indeed, the answer to this one is plus minus 6. All right. Good. Moving on from there, remember that this radical just tells you how many times to deal with a number inside of it. Turns out it can be any number, just like we looked out before. 4, you can have a cube root, which is 3. You can have a 50th root, which is insane. You can have a 100,000th root. It doesn't matter. You can go as far down the rabbit hole as you want, okay? The idea is that whatever number is here tells you how many times a number times itself should give you the number inside the radical. So if I put a 10 in here, it would ask what number times itself 3 times will give you 10. Now, if you put that in a calculator, you can get something crazy. We're not working that out. What number times itself 50 times will give you 1,000,000? Again, I have no idea. We ain't working that out. What number times itself 100,000 times will give you whatever this is? I don't know. We ain't doing that, okay? But as you can see, cube roots and other roots can get pretty crazy really fast. So we're not going to do any crazy roots for our purposes in middle school. We're going to be just kind of sticking with second and third for the most part, okay? So let's do that. Hang on, sorry, I got lost there for a second. Okay, so let's do that. What is the cube root of, let's say, 8? Okay? What number times itself 3 times will give you 8? What I encourage people to do is start from 1 and go up. So let's try that. Let's go 1 times 1 times 1. That is not it. Let's go 2 times 2 times 2. What is 2 times 2? 4. What is 4 times 2? 8. Aha! Now sometimes when people see 2 times 2 times 2, they immediately think 2 times 3 and they go 6. But no, sir. 2 times 2 times 2 is not 6. 2 plus 2 plus 2 is 6. Remember, we said at the start of this, exponents are about multiplication, not adding. Okay? So 2 times 2 times 2 is 8. So indeed, our answer to this one is 8. Now remember before we said we have plus and minus on answers that are even. The reason for that, or sorry, wait, this isn't 8, sorry, y'all. This should be 2. This should be 2. Sorry. We just did it. It's right here. So, the cube root of 8 is 2, and it is not plus and minus 2. Let's look at why. Minus 2 times minus 2 times minus 2 would give us positive 4 times minus 2, which would give us negative 8. But negative 8 is not 8. Okay? There's a difference between owing $8 and having $8. A really big difference. So with your odd numbered roots, you always keep the sign of whatever is in there. Let's take a look at another one. What is the cube root of negative 1 then? pause me, give it a shot. Okay, if you've unpaused me by now, then you know 1 times 1 times 1 is a positive 1. We don't need that. So then it has to be negative 1. Because the numbers you multiply have to all multiply times themselves, so they all got to be the same. Negative 1 times negative 1 is positive 1, and positive 1 times negative 1 is negative 1. Okay, so the answer to this is negative 1. And that is it. It's not plus minus 1, it's just negative 1. When you have odd numbered roots, keep the sign of whatever's in there. When you have even numbered roots, it's plus minus every time. Some of you may be asking what happens when you do the square root of a negative number. We'll talk about that in a minute. But for now, I want you to practice these cube roots. Remember, the technique I've given you is simply to start at 1 and go up until you bump into what you need. Okay? I recommend you write it out like this on a paper, as if you have other answers, you might bump into them simply by just looking over to the right and seeing if you've already multiplied it out. Okay? Here, let's not erase that. Let's just move that over. So let's try. You go cube root of negative 8, go square root of 16, go cube root of 64, go cube root of 27, go square root, ooh, it's getting kind of sloppy down there, good square root of 100, and go fourth root of, I'm having to work it out, do fourth root of say 16, and do the fifth root of negative 243. Don't pause yet. Do not pause yet. I gotta make sure this one turns out friendly. Yeah, it's fine. Yeah, it's fine. Okay. Alrighty. Enjoy. Pause me now. Give it a shot. Okay, hopefully you've paused, because I'm getting ready to give answers. Okay, let's begin. So this one right here, if you filled out your little chart on the side, which is the first thing I would do, I'll go ahead and just fill out a chart. So 1 times 1 is, so 1 3 times is going to give you 1. 2 3 times is going to give you 8. 3 3 times is going to give you 27. 4 3 times is going to give you 64. And 5 3 times is going to give you 125. Okay? That at least gives you something to work with, so you're not having to think so much. And the idea is to work smarter, not harder. Very important, as really I'm sort of trying to prepare you guys for your ACT at the same time as giving you these lessons by integrating strategies and harder problems. So you're going to get 2 for 1 here. This saves you energy, which is important on tests like those, which are 4 hours long. Like, you need to save your power. So write it out on the side and just reference it. So the cube root of 8 should be 2. And this is a negative 8, so I should have a negative 2 here. Okay, done. The cube root of 64 should be 4. And is positive, so I'm going to leave it positive, as that is a odd number. Remember, only even numbers have a plus or minus. Remember, we looked at y somewhere in here. You can rewind it. Oh, over here. We looked at y over here. Okay. So this should be a positive 4. Our next one should be positive 3 right here. Okay. Because the 27 is positive, it's not negative, and this is an odd number, so we're going to keep the signs. The square root of 100 should be 10, and we should have a plus minus here because this is an even number, so we should be seeing 2 answers. Anytime you have an even number on a root, you should have 2 answers. Okay? The square root of 16 should give us a 4, and again, we should see a plus minus here because that's an even number, and we should have 2 answers anytime there's an even number in the radical. The 4th root of 16, so what number times itself 4 times, should be 2 times 2 times 2 times 2. Because these 2 will give us 4, these 2 will give us 4, and 4 times 4 gives us 16. Now this is an even number, so we should see a plus minus on it too, because this is an even number. And all even numbers have 2 answers. The 5th root of negative 243, which is a crazy answer, first of all should be negative, okay, negative, and your answer should be 3, okay? If you do 3 times 3 times 3 times 3 times 3, you get 9, 9. Notice I do these in pairs, so it just makes it easier to see and keep up with. You're welcome to do the same technique too if it helps you. 9 times 9 is 81. And 81 times 3 is 243. The answer itself is negative, so we need these 3's to be negative. Ta-da! The shorthand way to remember if it's negative or positive is just if you have an even number up here, you have 2 answers, plus and minus. If it's an odd number, then just take the sign of whatever's in there. It's going to work out. If the sign in here is negative, the answer is negative. If the sign in here is positive, the answer is positive. The end. So don't try to joggle your brain a whole lot with like all those signs if it's a little intimidating, but I think most of you probably kept up with it just fine. Okay, let me give you a couple to take home and enjoy yourself. And then next time we will talk about Pythagorean, and we will talk about how to use squares to cancel out square roots. Okay, so here's some practice problems you can keep on your... Well, we're only using half the screen? Oh my lord. Wow, that's crazy. All right, let's have a look. Here are your practice problems to keep home. Feel free to rewind when you need to, okay? We're going to do the cube root of 27, the cube root of negative 64, the square root of 25, the cube root of negative 125, the 5th root of oh my god, that number is so big, I'm not doing that. Negative 1, the 4th root of yeah, I was about to give you something crazy. 4th root of 625, and that one's kind of crazy. And the 7th root of 1, and the square root of 100. Right back where we started. All right. Give these a shot. Pause me now. I'm going to give you the answers, and then we're going to dip out for today. I'm trying to keep these at about 30 minutes each, so it just makes it a little more digestible for you. All right. Okay, here we go. The cube root of 27 should be 3. The cube root of negative 64 should be negative 4. The square root of 25 should be 5. Put a plus minus on it. The cube root of negative 125 should be 5 with a negative on it. The square root of square root of 100 should be 10 with a plus minus on it. The seventh root of 1 should be 1. Okay? The fourth root of 625, crazy number, should be 5. And remember, that's an even number, so I should have a plus minus on it. The fifth root of negative 1, this is an odd number, so there should be, just keep the sign in there, should be negative 1. Okay, and let's prove it real quick, because repetition is the mother of remembering. So negative 1 times negative 1 is positive 1. Negative 1 times negative 1 is positive 1. Haven't done anything with this, bring it down. 1 times 1 is 1, and 1 times negative 1 is negative 1. Ta-da! All right, so that's how those work out when we talk about odd or even numbered roots. All right, hopefully that's clear. If not, leave me a comment, call, text, on campus, or any of the other methods we've discussed, okay? Email, whatever. Alrighty, have a great rest of the day. I will post your quiz tonight, and pay attention to the due date on it. I'll move... No, I ain't gonna move it. Well, no, I ain't gonna move it. We're gonna keep it Sunday night, straightforward. It's literally just gonna be these. It's gonna be these. Like, it's not gonna be these exact problems, but if you get it here, you're gonna be fine on there, okay? It's gonna be squares, square roots, and then some of the basic solving one-step equations, things you spent like your whole last year doing, so you're gonna be fine. Okay, see you soon.